to Panel Educate. In this video series, we'll be looking at least common multiples and highest common factor. And I'm expecting at the end of this video series, you should be able to solve problems on quantitative reasoning involving SCM and HCF. You should be able to find the HCF or LCM of a given whole number, and should be able to identify the common multiples of a given whole number, and you'll be able to find the LCM of a given whole number by factor method, multiple method, and index method, and so many other things that I'm expecting you to learn here. So let us start. We'll look at what LCM stands for. We said LCM actually stands for lowest common multiple, and HCF stands for highest common factor. Now, for you to know the difference between these two is to know the difference between a multiple and a factor. Right? I will still explain further as we go on, but what exactly is a multiple of an integer, which is a whole number? Now, if you're given to find the multiple of, say, a number 3, okay, so if you're given to find a multiple of number 3, now 3, the multiples of 3 is just like you are adding 3 to it. So if you add 3 to this particular one, it's going to give you 6. Then you add another 3, it's going to give you 9. Add another 3, it's going to give you 12. Alright, so that's a multiple of 3. Now, if we're asked that we should find the factors of a number, that's 36. A factor of an integer is any integer that divides the integer with no remainder. Okay, so a factor of any number, that's a whole number of any integer, is a number that divides that particular number without any remainder. For example, if we're to find the factor for 36, the factors of 36, so we know that 1 is a factor of 36, 2 factor of 36, 3 is a factor of 36, 4 can divide, you can use 4 to divide 36 without any remainder. Likewise 6, 9, 12, 18, 36 is 2, then 36 and 36 is 1. So these are the factors of 36. So we use the LCM and HCF to compare 2 or more integers, right? So LCM of a given numbers, if you have 2 integers, is the smallest number, that's the smallest whole number that appears in both of their timetables. That is the smallest integer that is multiple of both numbers. Okay, for example, now if we have you want to find the LCM of 4 and LCM of 20. Now what you need to do is let's find the multiples of 4. So we'll start with 4, add another one 8, another one 12. Those are multiples of 4. Another one 16, okay, 20 with another 4, 24, another 4, 28, on and on like that. Then the multiples of 5, okay, let's just look at 5. Sorry about that. Okay, let's only look at just to find the LCM of 4 and 5. Okay, so multiple of 5, we'll start with 5. 10, okay, plus another 5, 15, another 5, 20, another 5, 25, another 5, 30, okay, on and on like that. Okay, now the SCM, you see that the number that first appear to be the same in multiples, that's the lowest common multiples, because you can have all other multiples that are the same as time goes on. Okay, this is 32, okay, this is 36, and this is 40. All right, you can have 35, okay, and you can also have 40. Now this particular one, this particular 20 appears first, okay, and this is the lowest common multiples that you can have. 4 and 5 are not the same, here are not the same, these are not the same, these are not the same. So this 20 and 20 appears to the first number that appears in both lists of the multiples. Okay, then so this is the lowest. This is the lowest common multiples. Look at this. This is another one. Okay, this is another one that appears in the two lists. All right. Okay, that's another one that appears, but this particular one, okay, is higher than this. All right, so the lowest common multiples that appears in both lists is 20. So therefore the SCM of 4 and 5 is 20. Is 20. Okay, now that is a simple way to know what SCM is all about. Now for HCF, which is the highest common factor, highest common factor. Now the highest common factor of two integers, that is the largest, is the largest whole number that divides both numbers without leaving a remainder. For example, if we're asked to, if we're to look at the highest common factor, to look at highest common factor for 24 and 16. All right, so this is 16 and we have 24. We have to find the highest common factor. Now let us look at the factors of 16. Those are the numbers that can divide 16 without any remainder. So you can have 1, 2, 4, 8, then we have 16. Those are the numbers that can divide 16 without any remainder. Then we have for 24, 1, 2, 4 can divide it, 6 can divide, 8 can divide it, 12 can divide 24 without any remainder, 24 can divide 24 without any remainder. Now, highest common factor, okay, for the two is 8. Okay, this is a factor, 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 this is a factor. Okay, but this 8 and this 8 is the highest common factor. Okay, factor that is common to the two of them. That's the highest common factor, and it can divide both of them. If you use 16 to divide, 8 to divide 16, you're going to get 2. If you use 8 to divide 24, you're going to get a 3. Right, so this is the highest common factors. That's the highest common factor for both of the integers, 16 and 24. All right, so let us look at prime numbers. Now, prime numbers are whole numbers greater than 1, and they have two factors only. Prime numbers can only be divided by 1 and the number itself. So prime numbers are divisible only by number 1 or itself. For example, you have 2. Okay, 2 is actually a prime number. Okay, 3 is actually a prime number. Okay, 5 and 7. Now, one thing again in this series is that prime numbers exclude 1. Okay, prime number exclude 1. So 1 can never be a prime number. So prime number starts from 2. Okay, prime numbers can never be 1. Okay, so from 2 now you have 2, which is divisible by 2 and 1. 3 is also divisible by 3 and 1. 5 is also divisible by 5 and 1. 7 is also divisible by 7 and 1. Right, so you cannot have prime numbers cannot have multiple factors. It's just 1 and itself. Okay, so you can also have different numbers. 11, okay, is a prime number. 13, a prime number. 17, prime number. 19, 23, okay, 29. All these, they are prime numbers. So let us look at prime uh, factors. Let's look at prime factors, and prime factors are factors of a number that are themselves prime numbers. Okay, they are numbers that we can have prime numbers as their factors. Okay, that's another way to say it. So we can write every non-prime numbers as a product of its prime numbers. For example, if we are to express this number, let's pick 12. If we are to express 12 as the product of its prime factors, all right, so we know that 2 is a factor of 12. Okay, let's start with 1. 1, 2, 3 is a factor, 4 is a factor, that is the 4 times 3 can be 12. Okay, then we have 6. Okay, 6 is a factor. Okay, then we have 12 is a factor. So if we're to express 12 as the as a product of its prime factors, so you know that 1 cannot be prime number. We know that 4 cannot be prime numbers because 4 has multiple factors, but 3 is a 2 is a prime number, 3 is a prime number, 6 cannot be prime number. Okay, then 12 not prime number. So the only prime number that we have here are only 2 and 3. 2 and 3 only. So how do we express 12 as a product of its prime number? So we can have 2 multiplied by 2, that is 4, then multiply by 3. Okay, that will give us 12. All right, so we only have prime numbers as the product of 12. Don't forget that we can also have 6 multiplied by 2 as 12. We can have 4 times 3 as 12. We can have 12 times 1 as 12. We can have, 3 times 4. You can have several products as 12. But here we have a non-prime number. 6 is a non-prime number, so we're not going to. 4 is a non-prime number. 12 is a non-prime number. So to express um, 12 as product of its prime number, definitely this is what the answer should be. All right, so let us look at composite numbers. Now, composite numbers can be defined as the whole numbers that have more than 2 factors. Whole numbers that are not prime are composite numbers. All right, so it means that whole numbers that are not prime are composite numbers because they are divisible by more than two numbers. Then they are divisible by one more factors apart from one and the number itself. Okay, they are divisible by one fact one by one and then the number is itself. Okay, for example, um let's find the composite numbers. Okay, there are less than 20. Okay, we have 4. Okay, it's a composite number. 6, 8, 9, 10. Okay, 12, 14, 15, 16, then 18. All right, so if you have 4, 4, 2 is a factor, 1 is a factor, 4 is a factor. Okay, so this is more than you have 2 that is joining 1 and 4 itself. So that's why these are composite numbers. 6 also we have 3, 2, 1, and 6 itself, as factors. For 8, you have 1, 2, you have 4, then you have 8 itself. Okay, so that's why we have all this. So all the numbers, all the integers that are not prime numbers, they're actually composite numbers. All right, so now another thing that we can discuss here is what I call twin primes. Okay, twin primes, they they are prime numbers whose difference is true. Prime numbers whose difference is true. For example, um, 5 and 7. We know that they are prime numbers. So, but see that the difference between 5 and 7 is true. Okay, so 5 and 7, they are prime twin. Call them twin prime, rather. So they are twin prime. Okay, you can also have 7, 11. Okay, you can have 13. Okay, 7, 11, 13. Okay, all these, they're just prime twins. Okay, that's twin prime, so rather. Okay, that is what we call twin prime. Also 29, okay, and 31. Difference between 29 and 31 is 2, so these are twin primes. All right, so let us look at finding LCM using factor method. For example, we're given to find the LCM of these numbers. Let's say we're given to find the LCM of 12, 12 and 18. So we have to find the LCM of 6, 12 and 18. So what we need to do is to express all of these numbers as the product of its prime factors. Don't forget what I said, product of its prime factors. So the product of its prime factors, don't forget 2, 3, 5, 7. Okay, they are prime factors. Okay, now product of this one, which is product of its prime factors, will be 2 multiplied by 3. Okay, this one, if you express it in the product of its prime factor, we're going to have 2 multiplied by another 2 multiplied by 3. Okay, if we were to express this as the product of its prime factor, we're going to have 2 multiplied by 3. Okay, that is 6. Then multiplied by another 3. That is 18. Okay, that one has been expressed. Now, how do we find the lowest common multiples? All right, now in this now, to find the LCM, we have 2 here is common, you pick the 2. We have 3 here is common to all of them. We pick another 3, multiply by 3. Then we have 2 and 3 that are here, that are not common. Then we pick multiply by 2. Okay, then multiply by 3. Okay, so if we do, so that will be 2 times 3, that's 6 times 2, 12. 12 times 3, that will be 36. So the SCM of 6, 12, and 18 is actually 36. All right, so let us look at other examples. If we are asked to find the LCM of 3, okay, let's say we're told to find the LCM of 3, okay, another LCM 15, we have 21. So if we're told to find the LCM of these 3, said you're going to express this particular one as a product of its prime number. So this one is just 3. Okay, if you have maybe 1 times 3, okay, 1 times 3 is just but you know that 1 is not a prime number, so you don't put 1. So this is 3. Then for 15, we have 3, okay, multiplied by 5. Okay, that is the prime numbers that we can see there, which we can use to get 15. Then for 21, we have 3 multiplied by 7. It's going to give us 21. Right, so for us to find the SCM, okay, the SCM of this, we're going to have, so just take what is common. This 3 is common, okay, then multiply by, then we have 5, okay, then we have 7. All right, so if you do that, 3 multiplied by 5, that's 15 multiplied by 7 is 105. So the SCM, okay, of 3, 5, 15, and 21 is 105. That is how to do the SCM by factor method. All right, so now using the index method to find the SCM, what we're just trying to do is that we are given set of SCM, set of numbers rather, whose SCM is to be found as the product of their respective prime number factors in index form. So what we then do is that the SCM is the factor from the list with the highest power or index for each of the prime factors involved. Okay, for example, if we're given to find the SCM of 8 and 12, okay, so we know that 8 will be 2 multiplied by 2, well, that is 4, then multiply by another 2, that is 8. Okay, then we have 12 to express in the product of its prime, 2 multiplied by 2, then multiply by 3. Okay, which is 12. Now for this to balance, you can also add this one, okay, multiply by 3 raised to power 0. Okay, this is 3 raised to power 1. Okay, then we have all of them, this 2 raised to power 1. All right, 2 raised to power 1. Now the common factors here, they are 2 raised to power 3. Okay, because this is actually 2 raised to power 3. Okay, maybe multiply by 3 raised to power 0. Then this one is 2 raised to power 2 multiplied by 3 raised to power 1. Now the highest common multiples here, the highest common, the common factors, they are 2 raised to power 3 and 3 raised to power 1. Now this is the highest. Now between this and this, 2 raised to power 3 and 3 raised to power 2, 2 raised to power 3 is highest. Okay, then between 3 raised to power 0 and 3 raised to power 1. 3 raised to power 1 is the highest. Then your answer will be 24. That's 2 raised to power 3. That's 8. Multiplied by 3. That's 12. Now, that is looking at the power, to get what we want, having expressed the two numbers in the product of his prime. Now, we can also use a long division method, which is one of my favorites. Can also use long division method. Let me just get that one done. All right, so we can use long division method if we are asked to find the LCM of 63 and 108. So what I need to do is to come here. Okay. All right. Put my 63 here. Put my 108 here. All right. So I will start dividing it by the smallest number that can divide both of them. So I will start with 2. Okay. 2 here. Okay. It doesn't go. I will write 63. But 2 can go here. I will write 54. Okay. I'll go again with 2. 2 cannot go here. I'll write 63. Okay. But 2 can go here. I'm going to write 27. All right. So 2 cannot go again. I will, let me pick 3. 3 here. Okay. Will give me a 21. 3 here is going to give me a 9. Okay. I'll come over here again. 3 here. It's going to give me a 7. 3 here is going to give me a 3. Okay. I can pick 3 also. 3 here. Okay. Can't give me anything. So I'm going to repeat the 7 here. 3 here. Go to 1. Then the only one that can go down is 7. This 1. Then 1. All right. So until the 1 and 1. So now my LCM are just the numbers that are here. Okay. This is my LCM. So my LCM will be this 2 multiplied by 2 multiplied by 3. Okay. That's the 3 times 3 times 3. Then multiplied by 7. So if I do that, 2 multiplied by 2 is 4. Okay, is 2 raised to power 2 multiplied by 3 raised to power 3 multiplied by 7. Okay, so we have 2 times 2, 4. 4 times 27. Then multiply by 27. Do your calculation, you're going to get 756. Okay, so that is another way of expressing, finding SCM. That's the index method. One of the things that this one is the repeated long division. Okay, so you can also look at those using the factors, the one I discussed before. All right. So we look at finding the highest common factors before, where we discuss how you can do that with just finding the multiples of such numbers. Then you can quickly pick the highest common factor there. Now you can also use the index form to find the highest common factor. For example, if we were to find the HCF, that's highest common factor of say 48 and 144. Okay, so what do you need to do? Now you just do the same thing. To write 48 and 144, we start with the lowest number that can divide both of them, or divide any. So start with 2. All right, 24, 72. This one 2 can go here. All right. Okay, 2 years, that's 3. That's 9. 3, 3, that's 1, 9. Then 3 here, 1. Now, what you do here is to check the number that you used to divide, and they divide both of them. Okay, this one divide both of them. Okay, this one also divide both of them. This one divide both of them. This one divide both of them. This one also divide both of them. But here, this one, you can just this one just divide this one alone. Okay, so this one cannot be part of it. So your highest common factor is you pick 2 multiply, that's 2 raised to power 1, 2, 3, 4. okay, then multiply by 3 raised to power 2. So the highest common factor will be 48. Okay, that will be 48. That's 2 times 2. Okay, that is 4. 4 times 3, that's 2. That's 8 times 8. 2 times 4, that's 8. That's 2, 16. And once we have this, we're going to have the highest common factors are just 2, 2, 2, 2, and 3. Okay, that's not this particular one is not raised to power 2. It's actually raised to power 1, because these are the only ones we are using. So this particular one is not a common factor for the two of them. So that's 48. Now what we've been able to do is that for highest common factor using index form, you take the numbers that are here that can divide both of them. You multiply everything together, then you find your highest common factor. Okay, but if you are looking at lowest common lowest common multiples rather. So for lowest common multiples, what you just do is to multiply everything here, either is divisible by itself or by one of them. So you multiply everything here, then you get your lowest common multiples. All right. But for the highest common factors, you take the one that can divide both of them equally. You multiply together, you get your HCF. All right. All right. So let us look at differences between SCF, SCM, and HCF. All right. Now I will just use one example to explain that. Okay. SCM. Let me just do some other thing. Okay. SCM is a factor with the highest power. Okay. SCM is a factor with the highest. Okay. With the highest power. Okay. Highest power common to the given numbers. Okay. Highest factor common to the given numbers. That is LCM. So where we have the HCF as the factor. Okay, HCF is the factor with the smallest. HCF is factor with the smallest power. Okay, common to the given numbers. Okay, what do I mean? If we're to let us find the LCM and HCF, that's highest common factor, of 8, 16, and 32. Okay, now let us write each number in their index form. For example, 8 is 2 raised to power 3. Okay, 16 is 2 raised to power 4. Okay, then we have 32 as 2 raised to power 5. Okay, now the LCM is the factor with the highest power. Okay, the LCM is the factor with the highest power. Now the factor with the highest power is 2 raised to power 5. So the LCM is 2 raised to power 5. Okay, which is 32. All right. Now, what is the HCF? The HCF is the smallest power common to the two of them. I mean, to the three of them, common to the given numbers. The smallest or the lowest power is 2 raised to power 3. Okay, this particular one. So the HCF here is 2 raised to power 3, which is 8. Alright, so the HCF is actually 8. So those are the way to find the difference between HCF and LCF. And don't forget that you can also use the index form. Indexing, do the repeated divisions to do all this. Okay, so let me just do that. So if you want to use long division method, we're going to have these two. This one goes, this one goes. All right, and the SCM, like I said before, everything that I hear, that's 2 raised to power. So SCM is actually 2 raised to power 5. It's everything here now. But for the HCF, highest common factor, I said we're going to look at the numbers are here that can divide, the 3 of them. Okay, these 2 divide the 3 of them. Okay, we also have this, also divide the 3 of them. This one does. This one also divide the 3 of them. But this particular one, okay, it didn't divide this. It only divide this one. This one also only divide this one. So we have our HCF. Our HCF then will be 2 raised to power 3, which is the same thing as the way I did this other one before. All right. Now let us look at some quantitative reasoning in solving problems involving LCM and HCF. Alright, so let's look at some certain quantitative reasoning. For example, you are given this as a sample. You have these are samples. Okay, so you have 28, 2 raised to power 2 multiplied by 7. You are given, and you say you have to solve this. So 84. Now this is a box square. Okay, so and you know that 7 times 3 is 21. Now 21 multiplied by something is going to give you 84. So 21 multiplied by 4 is actually going to give you it's going to give you 84. So what you have to do is to know that, okay, this 4, this is going to be actually supposed to be 4 multiplied by 3 multiplied by 7. So, and this particular one is the box. So 2 raised to power 2 is going to give you 4. Okay, so definitely it's going to be 2 here. Then we have here 2 raised to something, okay, multiplied by 2 is going to give you 18. And you know that you can only multiply 9 by 2 and it will give you 18. Okay, so 9 multiplied by 2 will give you 18. Then this particular one is 3 raised to power 2 multiplied by 3. So what will be here is 2. All right, here we have 3 raised to power 2 multiplied by 5. That is 9 multiplied by 5. Then definitely what will be here is 45. So you can have different examples, you can have different exercises that you are being given to sort that one out. So this with this we've come to the end of our video series on LCM and HCF. I hope this has been very informative for you. I want you to subscribe to our video channels on Penny and Educate series. You can also share with your friends and loved ones. Please give this video a thumbs up, and we hope to hear from you. The comments and if you have any questions. All right. So in this video, in summary, we've been able to look at a factor of numbers. We said a factors, they are just the number that divides the number without a remainder. Okay, so I also discussed that a prime number is a number that is only divisible by 1 and itself. Okay, and we also discussed that 1 and 0, 1 and 0 cannot be prime number. They cannot, they are not prime numbers. 1 and 0 are not prime numbers. All right. We also discussed composite numbers. We said composite numbers, um, uh, they are numbers that can be expressed as the product of two smaller whole numbers. Okay, we'll discuss that. We also discuss how to find common multiples. I discussed the repeated divisions and all that. And we also discuss how to express numbers in index form. Okay, you can express 24, as 2 raised to power 2, okay, multiplied by the, let's say 2 raised to power, let's say 12, okay, let's say this is 12 multiplied by 2, okay, so this one can be 4 multiplied by 3, okay, multiplied by 2, okay, so you can have 2 raised to power 3 multiplied by 3, okay, that is expression in index form. And we also um, look at how we can find the HCF of a given number. Okay, we also look at how we can solve word problems involving SCM and HCF. All right, so please don't forget, like I said before, please subscribe to our video channel, share with your friends, and I will see you in the next series. Bye.